today we'll be discussing stability and determinacy of structures. So this is actually just an extension of your discussion from your basic statics class. But for now, we will be dealing with the more important discussions on both stability and determinacy. I believe this was already tackled, but it's a very short introduction yung dun sa inyong statics course. So today, we will be showing how to find stability and determinacy of different structures. So the structures that we will be discussing today are very civil engineering in applications. So beams, trusses, and frames. So yung stability nila at determinacy nila, merong way of calculating them. So merong quantitative way, tas meron din kailangan ng engineering judgment. So we will be, hopefully we'll be instilling engineering judgment in this lecture today. So you have to understand two concepts. Number one, stability, and number two, determinacy. So stability is basically the capability of a structure to resist motion. So it's stable if it does not collapse under normal conditions. Determinacy naman deals with the ability of knowing the unknown forces given only equilibrium equation. So yun yung concept ng determinacy. So unahin natin yung discussion on determinate structure. So structures are said to be determinate if your unknown forces can be determined using only equilibrium equations. So only equilibrium equations. So for example, this structure shown right here, to give you a recap. So this is a truss, para po sa mga nakalimot na kung anong truss. So this is a truss loaded as shown, supported by a pin and a roller at A and B. So this is a classic example of a statically determinate structure. All four bar forces, so ganun sa truss, diba? And reactions can be determined using equilibrium equations only. So you don't need any other compatibility equation. Now, just by looking at it, you should be able to determine that it is completely constrained, or it means that it will not move under the loading, under regular or basic loading, like as shown in this slide. So completely constrained siya kasi under the normal loads, it will not collapse, nor will it move, translate, or rotate. Now, compare it to this one. So the only difference is that the roller at B was changed into a pin. If you have that kind of change, it will now be statically indeterminate because your number of unknowns are now more than the number of equilibrium equations. So kaya kung papansin sa mga example from your statics class, it's always a pin and a roller or a cantilever. Kasi yun yung supports that are statically determinate. But if you have two pins, most cases would lead it to become statically indeterminate. But still, under normal loading, this will not move, so it's still considered to be completely constrained. Now, to help you understand or imagine yung ibig sabihin ng complete constraints, look at this example here. So instead of pin-pin, naging roller-roller si A at si B. Now, if you have purely vertical loads, purely vertical, this would still not move. But if you have just one horizontal component, this will now translate in the horizontal direction. So it is statically determinate because we can determine the reaction forces. Summation of moments at A, we find the reaction at B. Summation of moments at B, we find the reaction at A. So still mahanap natin yung vertical reactions. But it is only partially constrained. Ibig sabihin ng partially constrained, the motion will happen depending on the loading. So kung purely vertical yung loading, for example, no motion. But if you have horizontal loading, it would now translate horizontally. Now, ito naman, ginawa, baka daw kasi tatlong reaction yung kailangan to make it completely constrained. So, shown here, you add another roller at this point. So, 3 rollers na ngayon siya. This is still statically indeterminate. So, bakit ganon? Kasi, you cannot use the equilibrium equation of summation of forces X equals 0 kasi wala ka masasolve na reactions doon. So, in theory, dalawa lang yung equilibrium equation mo, moment and forces Y. So, still, you will not be able to find all reactions, kaya indeterminate pa rin siya. And it is also improperly constrained. Ano ang difference ng partially constrained sa improperly constrained? Si partially constrained, kulang yung support reactions to make it constrained. So kaya improper yung constraints. So this happens if your reactions are either concurrent or parallel. Ibig sabihin ng concurrent, they meet at a point. Ang ibig sabihin ng parallel, same uh, same line of action. So parallel lines of actions. So this one is a classic example of parallel reactions. Lahat sila papataas or pababa lang. So enough sana yung number, pero yung arrangement nila mali. Yun yung improperly constrained. Si partially constrained, kulang yung reactions mo to constrain the structure itself. Okay? So that's just an introduction of, by inspection, malalaman mo dapat kung determinate, indeterminate, partially constrained, improperly constrained, or completely constrained. So let's look at the meat of the topic. So first, we look at the stability and determinacy of beams. So beams muna. So the determinacy of beams is, again, it's dependent on the number of unknowns and the number of equilibrium equations. So, alamin muna natin, ano ba yung mga unknown kapag beams? So, the first type of unknowns are the reactions. So, let R be the number of reactions. So, if you have a pin, you have 2 reactions. If you have a roller, you have 1 reaction. If you have a fixed support, you have 3 reactions. So, basically, yung unknown forces for reactions is just the number of reactions. So, kung ilan yung reaction, kasama na agad siya sa number of unknowns. Now, per member, let M be a section of a beam where each section is not continuous through a joint. You have internal bending moment, internal normal force, and internal shear force anywhere you cut on a beam. So that means that per section, you have 3 unknowns. That's why your total number of unknowns is 3M plus R. So 3 times the number of members plus the number of reactions. So yun yung total number of unknowns for beams. So per member, you have 3 unknowns. Then per reaction, you have 1 unknown. So 3M plus R. Isipin naman natin, ilang equation naman ba available sa atin? So the available equations, let J be the number of joints. So this one are those that connect members to each other. So for example, this is a joint. You have 3 equilibrium equations per joint. Summation of forces X, forces Y, and summation of moments about that joint. So since you have 3 equilibrium equations per joint, so the number of available equations would be 3J, 3 times the number of joints. Now, pinag-usapan na natin in our discussion on conjugate beams the concept of internal connections. So yun yung internal hinge. If you can remember, the property of internal hinges is that at the hinge, the summation of moments becomes 0. So that's an extra equation. Kapag meron kang hinge like this, so nawawala yung internal moment. So that's an extra equilibrium equation. So yung technical term niya is equations of condition. So C here is just basically the number of hinges. So per hinge, you have one extra equation. So your total number of equations would be 3J plus C. So 3 times the number of joints plus how many hinges are there. So for beams, you have 3J plus C equations. So to know if beams are determinate or not, you just compare unknowns versus equations. So if they are equal, 3M plus R equals 3J plus C, determinate siya. Now, if the number of unknowns, 3M plus R, is greater than the number of equations, 3J plus C, it is considered statically indeterminate. So yun yung technical way of finding it. Get 3M plus R, get 3J plus C, then compare. Now, the difference between the two is called the degree of indeterminacy. So, doon yung malalaman kung gaano kataas yung degree of indeterminacy. As we used in previous discussions, the degree of indeterminacy is useful in knowing how many extra compatibility equations would you be needing. So, kaya yun yung gamit niya. Now, to illustrate that, let's look at this beam. So, you have here a beam that is cantilever, fixed at this end, roller at this end. Now, let's try to count 3M plus R and 3J plus C. Remember, M is the number of sections in a beam where no section is continuous through a joint. So, for example, this beam right here, M would now be equal to 2. Kasi ito isa, plus ito yung isa. So M equals 2. 2 members in the beam. Now, how about the number of reactions? So C fix, R equals 3. Roller 1, roller 1 din. So 3 plus 1, that would be R equals 5. So the total number of reactions is 5. Now let's count the number of joints. So this is one joint, this is another joint, and this is another joint. Therefore, J equals 3. Okay? Lastly, you have to find what is C. So C is the number of internal hinges. Since wala namang internal pin dyan or internal hinge, C equals 0. Okay? Next, we compare 3M plus R to 3J plus C. 3M plus R is 11, 6 plus 5. 3J naman is 9. So, therefore, your number of unknowns is greater than the number of equations. Therefore, this is second degree of statistical indeterminacy. Okay? So, naintindihan ba? Meron kayong na, anong tawag dito? Na-get? So, let's look at this one. So, this beam, M is the number of members, R is reactions, J is joint, C is hinge. So, no member continues through a joint. So, let's say, this beam right here. So, siya po ay fixed. Merong pin dito sa gitna or internal pin. And then you have a roller. So, in this lecture, I will show you the usual actual configurations of pins, rollers, fixed supports in real life. So, for example, si fixed support, in real life, ganito po siya ginagawa. So, you have a joint here and a joint na on this plane. So, hopefully, naka-imagine nyo ano itsura nito in real life. So, yan po itsura ng fixed connection. So, meron kang connection in both this plane and in this plane. Now, in real life naman, a roller is something like this. Nakapatong lang yung connection. So, hindi sila, ang nire-resist nyo lang basically is vertical reaction, vertical displacement. So, kaya roller yung, ano sa kanya, idealization. Okay? So, now let's count the number of members M. So, ano yung M dyan? So, M would be 1, 2. So, M is 2. And R, so tatlo sa fix, isa sa roller. So, bakit walang reaction sa pin? That's because that's an internal connection. Hindi siya external support. So, R would be 4. 3 plus 1. And then, J, so number of joints, 1, 2, 3. So, J is 3. And then, the number of internal conditions, C, ito lang, 1. Internal connection, C equals 1. So, 3M plus R compared to 3J plus C. So, 3M plus R is 10. 3J plus C is also 10. So, 10 equals 10. This one is statically determinate. So, ibig sabihin, pag binigay na problem sa inyo to right now, you should be able to determine the reactions using only statics. Kasi statically determinate yung beam. Okay? So, ito yung actually ginawa natin sa conjugate beam wherein we cut, tapos tinitin natin yung section lang na isa, kasi kabilang section lang na isa. So, yun yung concept ng internal hinge. Okay? So, now let's test your understanding. So, kaya natin ha? So, I will show different beams and you will determine if they are statically determined. So, now we will test your understanding and determinacy of frames. So, for each of the beams shown, you will determine if they are determinate or indeterminate. If indeterminate, you have to specify the degree. So, for this part of the video, you will be given approximately 5 to 10 seconds per beam to determine the degree of indeterminacy. If you need more time, you can just pause the video and play it afterwards. Okay, so first beam. So this beam is first degree indeterminate. So that is because of the extra support. So M is 1, 2, 3. R is 6, tatlo. J is 1, 2, 3, 4. And C is 2. So if you compute 3M plus R and compare to 3J plus C, mas mataas si 3M plus R by 1. So first degree indeterminacy. Next beam. Okay, so this beam is statically determinate. So If you got it wrong, so most probably it's because you did not consider this as a joint. So this is also a joint kasi no member is continuous through a point. So M now is 1, 2, 3, 4. R is 1, 2 plus 3. So 5. Tapos J is 1, 2, 3, 4, 5. And C is 1, 2. So if you compute that, it would be statically determinate. Okay? Last B. Okay? So this beam or this contraption is statically determinate. That's because M is 2, R is 4, J is 3, and C is 1. Compute 3M plus R compared to 3J plus C. Equal po sila. So this one can be illustrated by a simple beam. You have your roller. So M is equal to 1, R is 2, J is 2, and C is 0. So what happens is that 5 less than 6 yan. So therefore, this is unstable. So partial constraints happens if you have less number of unknowns than your equilibrium equation. So yun yung first one. The next kind of instability is due to improper constraint. So ito yung pinakita natin kanina na improper constraint wherein the reactions are either concurrent or parallel. So example ng concurrent is this one. So you have roller pin. So in theory, enough dapat yung number niyan. Kaya pag kinuha niyo yung 3M plus R niyan compared to 3J plus C, equal sila. So dapat determinate. Pero dahil nag-meet at a point yung reaction, so something like this, they are concurrent. So pag nag-summation tayo ng moment, for example dito, summation of moments about O, walang moment yung mga reaction, pero yung force na in-apply meron. So iikot siya about this point. So kaya siya nagiging unstable. Okay? Para concurrent reactions. So the other one is due to parallel reactions. Ito yung mas classic, yung tatlong roller. So tatlong roller, lahat sila parallel. So pag nag-summation of forces X ka, walang magre-resist doon sa force. So kaya unstable pa rin yung B. Okay? So yun yung concept ha. So if 3M plus R is less than 3J plus C, unstable siya due to proper partial constraints. Pero hindi porkit equal sila, proper na yung constraint. Kapag equal, you have to check if concurrent ba yung reactions or parallel. So that would also cause instability. Okay, so let us test your understanding. You will determine if the shown beams are stable or unstable. If they are unstable, you will have to determine what kind of instability is it. So is it due to partial constraints or due to improper constraints? So in the next parts of the video, I will show the beam before showing the correct answer. So you can choose to wait for the final answer, or you can just pause if you still need more time. Okay. So first, let's look at this beam. So this beam is unstable due to partial constraints. That is because M, so M is 2, R is 3, J is 3, and C is 1. So less than si 3M plus R kaysa kay 3J plus C. Okay, next beam. So this beam is stable. So equal si 3M plus R kay 3J plus C, if I'm not mistaken, or greater than, kasi hindi siya less than, and the constraints are not parallel nor are they coincident or concurrent. Okay, last beam. So this beam is stable. That is because all support reactions are not concurrent nor are they parallel. So ito horizontal, vertical. So this beam, although it looks unstable, it is stable because remember, roller support also provides support reaction either to the right or to the left kapag ganyan, or dito up or down. Okay, so stability and determinacy of frames. So frames are basically extended beams or connected beams. So frames are structures that contain multi-force members, and they are made to support different loads. So this is the more common structure in real life. So they are usually stationary and fully constrained. So remember anong multi-force member? So a multi-force member is basically a member that is acted upon by forces at least three different points. So like this one, these two members, kapag kinuha yung free body diagram nila, looks like this. Si AC, ayan, tatlo, A, P, and C. Now, you have to recap your concepts of statics. If you have a frame like this connected by a pin at C, so yung pin connection, dapat mag-o-oppose yung reaction. So if CX is acting to the right in AC, dapat kay BC maging to the left na siya. Kung ito papataas, dapat kay BC pababa na siya. So yan yung mga kailangan nyo i-recap for frames and frame analysis. So how to find reactions, how to find internal forces. Okay? Now, rigid frames are those frames that do not collapse when removed from supports. Hopefully, na-discuss na sa inyo ito nung inyong statics. So, ibig sabihin na ng rigid eye, for example, ito, pag inalis natin yung support, hindi na siya pin in a roller, will it collapse? So, magpapalit ba siya ng shape? So, for this one, kahit alisin mo yung roller at pin, yan pa rin yung shape niya, di ba? Hindi gagalaw yung, hindi magko-collapse yung frame. So, this one is considered a rigid frame. Even if you remove it from the support, it will not collapse. Compare it to this one. This is still a frame kasi meron kang multi-force member. Pero kapag inalis mo yung supports na yan, pin-pin, itong BD iikot. Imagine ba? So if you remove this one, it will now collapse. So this one is a collapsible frame. So it is only stationary because of the supports. If you remove it from the supports, hindi na siya rigid. Okay? Now, the determinacy of frames is the same as the determinacy of beams. You still compare 3M plus R to 3J plus C. M members are reactions, J joint, C conditions. Okay? So if it is greater than and indeterminate, and the difference is the degree of indeterminacy. Okay? Now to illustrate that, we show here a frame. So may multi-force member ka na. Again, remember, each member is it's not continuous through a joint. So for example, this one, M would be 1, 2, 3, and 4. So 1, 2, 3, 4. So M is 4. Now, the number of joints, the number of reactions, tatlo kay fix, dalawa kay pin. So 3, 6, 8. So R is 8. Now, the number of joints, so 1, 2, 3, 4, 5. So joints is 5. And then the number of internal conditions, C, ito po, is equal to 1. So dun lang may pin. Kasi ito, rigid connection yan. So hindi siya pin connection. So 3M plus R, that would be 20. 3J plus C would be 16. So therefore, this is 4th degree of indeterminacy. So kahit simple frame lang na ganyan, 4th degree of indeterminacy agad. Paano kaya pag ganito? So ito na yung mas common na frame in real life. You can imagine a house can be built like this, di ba? So pwedeng ganyan na yung frame ng bahay nyo, gawin nyo lang 3D. So, again, we count the number of members. So the number of members, 1, 2, 3, 4, 5, and 6. So 6 po, teka lang. So again, M is 6 for this one. Now, the number of reactions, pin in a rocker, so 2 plus 1. So R is 3. Now, the number of joints, 1, 2, 3, 4, 5, 6. So J equals 6. Always remember, reactions, the point of connection between reactions are still joints. So yun kasi yung common mistake, hindi nabibilang itong dalawa. So C, internal pins, wala. So walang pin connection between two members. So therefore, we compare R and 3J plus C. This would be 21, this would be 18. So therefore, this is 3rd degree of indeterminacy. Okay? Now, for frames, you can imagine the connection is no longer just between two members. Parang itong connection na to, tatlong member, or this one, tatlong member, ito tatlo din. So what if you have a pin at that connection? how do you count C? So if you have more than 2 members connected by an internal hinge, so you compute C using this equation. So it is summation of D minus 1 from 1 to H, where where H is the number of hinges or number of internal connections, and D is the number of members connected. So ulit ha, H number of hinges, so number of internal connections. D is the number of members connected. So per hinge you count D minus 1. So let's check this frame. So this frame has hinges at this point, and at this point. Can you imagine this point, tatlong member yung connected ng hinge. Dito naman, 4. Dito, 4 din. So, tiyatin ko paano nag-change yung pag-count, ha? So, M is 15. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, the number of reactions, tatlong fix, so 9. J, number of joints, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, J is 12. Now, dito nagkakatalo sa C. So, C is summation of D minus 1 from 1 to 3. Saan nakuha yung 3 kasi tatlo yung hinge. So, H is the number of hinges, tatlong hinge. Now, for example, for this hinge, what is D? D is the number of connected members, so 4. Dito naman, 4 din. Dito, 3 lang. So, yung summation would look like this. So, for this hinge, 4 minus 1. For this hinge, 4 minus 1. And for this hinge, 3 minus 1. So, mangyari dyan, 3 plus 3, 6 plus 2, 8. So, C is 8. So, ganun yung pag-count kay C kapag meron kang connection that has more than 2 members connected. So, then we count again 3M plus R to 3J plus C. So, 3M plus R, 45 plus 9, that would be 54. 3J plus C, 36 plus 8, that would be 44. So, this is 10th degree of indeterminacy. So, kahit ganyan lang yung frame, still considered a simple frame, you already have a very high degree of indeterminacy. Paano pa kaya kung ginamit na siya sa bahay? So, kapag bahay na siya, mataas talaga yung degree of indeterminacy. Kaya, very seldom na determinate yung isang frame. Okay? So, next is stability of frames. So again, the stability of frames is just like the stability of beams. The instability is either caused by partial or improper constraints. Kasi partial constraints happen if your number of forces is less than the number of equations. So for example, this one. So this one is pin, rocker, fixed pin. So ito again, papakita ko yung itsura ng connections in real life. Compare the connection between a fixed connection to a pin connection. So, si fixed connection, ganyan siya kinoconstruct in real life. You connect two planes. So, dito may connection, dito din may connection. Si pin, pansinin niyo, ito lang yung connection, wala dito sa connection. Ito, ibig sabihin, ina-allow niya yung rotation but not translation. So, yun yung difference nila. Now, let's count yung M plus R, J plus C. So, M is 3. So, 1, 2, 3. R would be 3, so pin and a rocker, so 2 plus 1, so 3. J is 4, 1, 2, 3, 4. And C, ito lang, internal pin, hindi yung internal fix. Kasi nga, C is number of hinges. So C would be equal to 1. Bakit hindi natin ginamit yung summation na equation? Kasi dalawa lang naman yung connected by this pin. So we just count it as 1. You can actually understand yung D minus 1. Imagine niyo to. 2 yung connected niya, di ba? So, D is 2 minus 1. So, 1 lang siya. Kaya C equals 1. So, 3M plus R, 3J plus C, you get 12 is less than 13. So, therefore, this is unstable due to partial constraint. Yung instability niya actually happens, nasaan ba yung instability? Dito, sa pin na to. So, dahil rocker ito, pwede itong mag-translate horizontally. Dahil pin yan, pwede siyang umikot. So, pwedeng iikot siya about this point. So, yun yung instability ng frame na yan. Now, the other one is due to improper constraint. So, improper constraint, again, happens if either concurrent or parallel supports. So, concurrent looks like this. So, they meet at a point. Even though tama, pin in a roller siya, rocker, dahil nagmi-meet sila at a point, yung reactions nila, concurrent, if you take summation of moments about this point, iikot yan buong frame na yan. Okay? Now, parallel naman happens this way. So, ayan, vertical, vertical, vertical. So, yung support on this frame, parallel sila. So, kaya unstable yung frame na yan. So, if you apply a horizontal force, for example, mag-move na to, di ba? Horizontally. So, now we will test your understanding with respect to frame. So, you will determine the stability and determinacy of the frame. Just like earlier, I will show the beam, the frame first, then you will determine if it is stable and determine it. So if it is unstable, you say why. If it is indeterminate, you say by how much or what degree of indeterminacy. So first, this frame. So this frame is stable and statically determinate. So stable siya because 3m plus r equals 3j plus c. So even though it looks unstable because of these two becoming two force members, if the load is not at the end, so kahit saan dito, magiging hindi na siya two force member. So, hindi na ngayon concurrent yung support reactions dito, so stable na siya. Okay? So, next frame. So, this frame is unstable due to partial constraint. So, because of the pin and the free end, so makikita nyo yung 3m plus r less than 3j plus c in this case. So mangyayari dyan, this part of the frame, the vertical, is free to rotate because of the pin support here and free end here. Okay? Last frame. So this frame has a hinge at this end connecting three members. So you will have to use the formula for determining C equal to the summation of D minus 1. So in this case, C is 3 minus 1. So 2. C is equal to 2 in this case. Now, if you count M, R, J, you will get that this is statically indeterminate to the third degree. So let's look at the last one, trusses. So beams, frames, and trusses. So let's just recap what is a truss. So basically, a truss is a structure wherein your members are only connected by smooth pins and the loadings are in the joints only. So lahat ng members ng isang truss ay two force member. So trusses are applied for roofs. So this is a roof truss. So paano na-idealize yung pag-connect na only loaded the joints? Ginagamitan po siya ng purlins. So for you to understand the idealization, your purlins, so these members should be applied at the joint. Para ma-idealize mo ngayon na yung force galing sa yero is only applied at this joint. Yan, ganito rin siya. Purlin, purlin, purlin. You can imagine if you directly connect the roof to the truss, parang distributed load na dapat yung applyan niya. Another reason for using purlins is rust proofing. So imagine yung pag kinalawang yung bubong or yung yero, kapag nakadikit siya directly dun sa truss, magkakaroon ng kalawang yung truss. So kaya ginagamitan ng purlins para dun lang makakonect yung roof. So kapag nasira na yung yero nyo, papalitan nyo lang yung purlins. Hindi nyo papalitan yung buong truss. Okay? So another common application of trusses are bridge. So bridge trusses are idealized this way. So paano naman na-idealize na at the joints lang ina-apply yung force, ginagamitan ng stringers. So ito po yung paganyan. So kung ito yung deck, so saan dumadaan yung mga tao, mga sakyan, yung force ma-apply dun sa stringer, so si stringer magdadala ng force dun sa joint. Kaya yung truss would now be idealized. So nag-apply lang yung force sa dulo. Okay? So those are trusses. So hopefully you can remember your ES11 lessons. So the determinacy of trusses, again, we check yung unknown forces compared to equilibrium equations. So again, first is the number of reactions. So rollers, pins. So kung ano yung number of reactions, yun yung number of unknown forces or unknown reactions. Now for trusses, you usually see only pins and rollers or rockers. You don't see fixed supports for trusses kasi nga wala dapat moment. So kaya pins or rollers lang ginagamit. Now, if M is the number of truss member, remember, for truss members, all members are two force bodies. So unlike frames, si Trusses, per member, isa lang yung unknown, kung ano yung bar force. Kasi wala kang internal M, internal shear. So for Trusses, per member, one unknown. Therefore, your total number of unknowns is M plus R. So kung ilang members plus kung ilang support reactions. So yun na yung number of unknowns. Now, si equations naman, let J be the number of joints. So per joint, you only have two available equations. Summation of forces X, summation of forces Y. Wala kang available na summation of moments. Dahil nga two force body lang yung mga members. So, ibig sabihin, per joint, you only have two equilibrium equations. So your total number of equations is 2J. So wala kasing internal pin sa truss kasi nga connection nila dapat at the ends lang. So wala kang internal pin. Therefore, the determinacy of trusses is just computed by comparing M plus R to 2J. So hindi na siya 3M kasi per member isa lang yung unknown. Tapos hindi rin siya 3J kasi dalawang equation lang meron. So kaya M plus R equals 2J. If it is greater than equality. If it is greater than 2J, indeterminate. And then the difference is the degree of indeterminacy of truss. So there are trusses that are statically indeterminate. Okay? So again, to illustrate that one, let's look at this one, a basic truss. So let's count the number of members. Again, no member is continuous through a joint unless hindi siya nakakabit doon sa joint niya. So, for example, this one, 1, 2, 3, 4, 5, 6, 7. So, therefore, M equals 7. Tapos, R, so pin and a rocker, so R is 3. And the number of joints, 1, 2, 3, 4, 5. So, J equals 5. So, M plus R is 10, 2 times J is 10. So this one is statically determinate. Again, if a truss looks like a truss, it is statically determinate. Yun ang ano dyan, yun ang basic clue. For example, this one. Does this look like a basic truss to you? So parang may mali, di ba? Parang may sobra. So let's check. So M is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, 11 yung members. Hindi po to dalawang member ha, ito tsaka ito. Kasi wala namang pin sa gitna. So, ibig sabihin, nasa likod siya. Ito nasa harap. So, 1, 2. So, ulit ha, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, the number of reactions, pin in a rocker, so R equals 3. Number of joints, 1, 2, 3, 4, 5, 6. So, walang joint sa gitna. Ayan, walang pin nakalagay. So, J equals 6. So, compare M plus R to 2J, you get 14 greater than 12. So, second degree of indeterminacy. Again, sabi ko sa inyo kanina, kapag hindi siya mukhang trans, malamang indeterminate. Pansinin nyo, pag inalis nyo yung dalawang diagonal, ito tsaka ito, mukha na siyang trans, di ba? Mukha na siyang simple trans, ganun. So, dalawa yung inalis mo, so yun yung degree of indeterminacy. So, yun yung lesson dito. Pag hindi siya mukhang basic truss, alisin niyo yung members to make it a basic truss. Tapos kung ilan yung inalis nyo, yun yung degree of indeterminacy. Okay? So, ganun po siya. So, determinacy of trusses. Next is stability. So, how do you know if trusses are stable or not? So, same concept. Partial constraints. So, if it is less than. So, M plus R is less than 2J. So, ito example niyan. So, again, it doesn't look like a simple truss to me. Based on my experience, kaya hindi siya stable truss. So let's check kung tamang aking idealization. So M is 8. 1, 2, 3, 4, 5, 6, 7, 8. R is roller pin. So 3. J is 1, 2, 3, 4, 5, 6. So J is 6. So M plus R is 11. 2J is 12. So less than. So this is unstable due to partial constraint. Paano siya magiging stable? Maglagay ka ng vertical, ng member dito na horizontal or maglagay ka ng vertical dito. Yan. Stable truss na siya. Tatama na yung M plus R tsaka 2J. Okay? That's first one. Partial instability. Next one is externally unstable. So it is externally unstable if your supports are either concurrent or parallel. So example lang concurrent. Pansinin niyo yung roller, unlike this one, ginawa na siyang horizontal. Kapag ginawa mo horizontal, magmi-meet ngayon yung lahat ng reactions dito. So that is a concurrent reactions. So what happens if you take summation of moments about this point, iikot yung buong truss. So para mag-move siya as a rigid body, pero iikot siya to tataas. Kasi nga walang support reaction na vertical. The next one is parallel. So ganyan, tatlong roller. So, parallel sila. So if I apply a horizontal force, gagalaw na yung buong truss. Gusto nyo ba yun yung bubong nyo gumagalaw pag humangin? So kaya kailangan at least may isang pin. Okay? So but for trusses, there's also a concept of internal instability. So this happens if the arrangement of members are improper, such that it does not hold at least one of its joints in a fixed position. So example is this one. So if you compute for m plus r equals 2j, so m is 13, r is 3, j is 8. If you compute that one, m plus r is 16, 2j is 16. So 16 equals 16 pa din. Pero unstable siya dahil dito. So this is unstable because there is no restraint connecting CF or BE. So kung nilagay mo yung extra member na to dito, stable truss na sana yan. Pero dahil wala, ang mangyayari dyan, itong square na to would rotate. So magko-collapse yung truss dahil dito. So imagine kung paano siya mag-rotate. Parang ito, gagalaw, mag-move to the right. Tapos ito, bababa, move to the right. Para siyang mag-form ng parallelogram. So meron siyang instability. So kahit m plus r is 2j, hindi tayo sure na stable siya. That's because of the arrangement. So this is the hardest kind of instability, yung pinakamahirap i-check kasi wala siyang mathematical checking. So it's about engineering judgment. Okay? Gets ba? So three kinds kapag trusses, ha? Partial, external, or internal. Now we will test your understanding of the determinacy and stability of trusses. So if it is unstable, you say if it is because of partial constraints, external instability, or internal instability. If it is indeterminate, you say the degree of indeterminacy. Okay? So this one is a truss. So please determine if its stability and determinacy. This one is stable and statically determinate. So if you count your m plus r and compare it to 2j, so they are equal. Now some of you might think that this is unstable because of this rectangular part, that's a likod. That is stabilized by this member right here. So without this member, this part would be unstable. But because of this member, stable na siya. Okay? Next truss. So this truss is unstable due to partial constraints. That is because m plus r is less than 2j. So as you can see, because of this roller support, this full part of the truss is free to translate this way, and this rigid part of the truss will rotate about this point. So pag nag-rotate about this point, ito gagalaw pa ganun, ito gagalaw pa ganun. So meron kang instantaneous center of rotation for this part. Ito naman, parang general plane motion. Itong buong truss. Okay? So, last truss. So this truss is stable and indeterminate to the first degree. So pag chinek yung m plus r is greater than 2j. So add yung m plus r. So although it looks unstable, it's actually stable because of the triangles formed. So may triangle ka dito, triangle ka doon, triangle ka dyan. So basically, stable siya. So meron kang 3 rigid triangles. So, and the indeterminacy is due to one of the supports being a roller. If you make this a roller, it should still be unstable because the supports would be concurrent at this point kung roller ito. So to make this stable and determine it, you put the roller either here. So this in this position. Or you can also put it in this position. So basta vertical. So yun yung mga pwede. Hindi pwedeng horizontal kasi magko-concurrent. Okay? You now have questions. Questions for this lecture. Okay? Kung wala na, so all of this can be seen in this reference. So yung structure analysis by Hibbeler. So meron ng 8th and 9th editions. So that ends our lecture for today.